When it comes to transformations, there's a couple of different ways of approaching them. So I'm going to list a couple of different methods and you can choose your favourite. Now we're transforming the exponential function today. Let's first look at how we can shift it up and down. So we've got our base, if you like, exponential function that looks like this, y equals e to the power of x. And we need to know the features of that before we're going to move it around. So we know that it's got an asymptote on the x-axis, we know that it goes through a y-intercept at 1, and we know that it comes in here like this and has a rough shape like that going up very sharply. So that's our starting point, the asymptote, the known intercept, and the shape. So if we're going to shift it up and down, the official way to think of this is that if you replace y with y minus something, it shifts it up. Or y plus h, it shifts it down. Now for many people this seems quite counterproductive and it seems like the opposite of what you might imagine. The other problem with it is that we don't often see equations written like, say, this, y minus something or y plus something. We're much more likely to see it written like this, y equals, and a whole heap of things on this side, e to the power of x plus or minus something. And that's what brings me to method 2. And method 2 is a little bit more practical because this is the form that we mostly see our exponential functions written in. So I think it makes a little bit more sense. I also like this method too because to me it seems very logical that if you've tacked something onto the end of your equation plus something, it's going to move it up. To me, up and plus seem pretty logical. And if you've tacked on a minus something at the end, that's going to move it down however many units. We do need to be careful though that when we look at it this way, we're not forgetting the original definition which brought us to this more practical way of doing it. Because if we get one that's tricky, we might need to revert back to this our original understanding. Now in practical terms, when we go to shift a curve up or down, if I have one like, for example, y equals e to the power of x plus 3, then I have my normal graph here, but I just need to lift everything up 3. So let's rub this one out. I'm going to start by drawing in my asymptote. It won't be on the x-axis anymore. It's moved up 3. So I'm going to find it here at 3. Put that in. And then think of your known point. It's normally down here at 1, but if you've moved it up 3, it will be at 4. So I can put those in. And then I just go in and rough in the basic shape and then label it, of course. Nice and straightforward. Now, when we're drawing an exponential function, you need to give your graph some scale. So you've got an intercept here, there are no other intercepts. It makes sense to give one other point so that sort of shows the sharpness. So to find your other point, just pick a value of x that's nice and simple, sub it into the equation, find out what y is, and that will give you a coordinate point. So always show your working so that if you mess it up, a teacher can see what you've done. When x equals, I'm going to say when x equals 1. Y equals, well I just need to sub 1 in here. E to the power of 1 is just e plus 3. Now, bear in mind we know e is about 2.7, so we're thinking here this is about 5.7-ish. So what I've found then is that when x is 1, y is about 5.7. Now don't write 5.7 because you'll be rounding off. Write e plus 3 because that way it's exact. Also saves you reaching for your calculator or actually investigating what that is, but keep in your mind what it is so that you can get a nice scale to the graph. We're done. Now, if I want to move the curve down, let's have an example where we move down now. This is where it can get a little bit trickier because you might need to find an x-intercept. So, in this example, let's say y equals e to the power of x minus, let's go 4. Alright, so imagine your original curve and drop it down. So, let's, instead of drawing our asymptote here, we'll move it down to minus 4. Our known point, which is normally here at the 1, is also moved down 4. So that'll be down here at minus 3, so that's easy. We've got that. Then we can rough in the basic shape, label it, and we're almost there. We need to put in another point. Now it makes sense to put in this very key point here because it's an x-intercept. So how do we find an x-intercept? We let y equal 0. Now always show your working for this because it'll stop you messing it up, saves you making a mistake in your head, and if you do make a mistake, an examiner will be able to see what you've done. Let y equal 0. So we need to rewrite this equation letting y equal 0. So start by just subbing in 0 for y. Now if I add 4 to both sides, I get 4 equals e to the power of x. Now I need to rewrite this as a log, okay? You might be a bit rusty on that, so let's go back a step. E to the power of x is 4. We write that as e to the power of x is 4. So x equals log of 4 with base e. So this is a natural log. That's what we call any log that has a base of e, a natural log. And that gives us the ln button on the calculator. So if you want to find what this really is, on the calculator you'd hit ln, and then you'd hit the 4, and then you'd press equals, and you'd see what this is. Easier for us though to actually label it log of 4, because that way it will be exact. So we can label this point and call it log of 4 with a base of e. And now we've got our 2 points, so we're showing the scale, we've showed both intercepts, and we've got our asymptote in there, and we've labelled the curve, so we're finished.